Hi, everybody. Thanks so much for joining us today. We have another really cool chat for you. My name is Tom. I work at Cheehaw Park and Zoo and Flint River Aquarium as an educator, and so I'm super excited to have you all joining me today for a really cool talk on an animal group or a group of animals that is really exciting to me because I've studied them a lot in the past, and that is what we call ectotherms. So we are going to talk about what ectotherms are and kind of compare them briefly to endotherms. And then we are going to talk about how ectotherms are impacted or influenced by different types of solar radiation. So to start, we're going to talk about what solar radiation is, where it comes from, why it's important, and then we're going to start to talk about ectotherms specifically, and again, how they are impacted by solar radiation and different levels or forms of solar radiation. So I figured we would start by talking about solar radiation itself and what it is. And to help us do this, I am going to share my screen because I have a PowerPoint that I think will help us understand this a bit better. So let me go ahead and share my screen. Okay, so I figured I'd start with talking about solar radiation because that's a lot of what our talk is going to focus on, and what that is and where it comes from. So to start, radiation and all of the different wavelengths of radiation comes from the sun. So our sun is a big star that is comprised of gases. So we have our different states of matter, right? We have our solids, our liquids, and our gases. So the sun is actually made up of hydrogen and helium gases. And so what solar radiation is, and the sunlight that we see and the heat that we get from the sun that's also coming down to Earth, it's all coming from the sun. And the way that this heat and this energy and this light is produced is from nuclear fission reactions, nuclear fusion reactions. And so essentially what's happening is the center of the sun in the core that you can see there on that diagram, in that core, there's so much heat and it's such a high temperature and there's so much pressure that these hydrogen atoms are flying around and just smashing into each other. And hydrogen atoms actually combine to form helium. And when those atoms are fusing together, they're releasing energy. So essentially, we're transferring mass into energy through these reactions. And so when those reactions take place, energy is released, and that energy is released in the form of electromagnetic radiation that's emitted from the sun. Now, that, like I said, that takes place in the core where it's really, really hot and there's a lot of pressure. And so what you'll notice is there's also other sections in the sun, such as that radiation zone and that convection zone, that emitted energy has to travel through before it gets to the surface of the sun, which is essentially what we see. And that's nice because that gives this radiation time to cool down before it's going to get emitted and you know transferred towards us on Earth. And so again, when these reactions take place, all of that energy is going to be emitted in different types of wavelengths, and that's what gives us our light and our energy and our heat. And so radiation, essentially, to put it simply, is the emission of energy as waves or particles through space or a material medium. So we know it has to travel through space, right, to get to us on Earth. And so to look at the different, I mentioned there's different wavelengths and forms of radiation that is going to move towards Earth from the sun and impact us in our everyday lives. We can get a good look at this spectrum. And so if we look at the top here, it's showing us some wavelengths and forms of radiation have more energy than others. So as we get further to the left, there's more energy. Where we get to the right, there's less. And so the one I want to draw your attention to begin with is where it says light, and you can see those colors. That's the spectrum of radiation that's given off by the sun that is visible to us. So that's what helps us see color. Different surfaces reflect different wavelengths, and that's what allows us to see different colors. Light that falls within those wavelengths are also what is believed to be the photosynthetically active wavelengths. So those are the wavelengths in the light that is going to allow plants to take in sunlight and energy and use that energy for growth, which is a big source of how we and all animals, including ectotherms, which we're going to talk about, are getting a lot of their energy is through plants that use that energy, make food, and then that food travels up the food webs and food chains, right? So that's super important to recognize that that photosynthetically light is found in that category. And then if you notice to the right of light, it says infrared. So infrared radiation is the type of radiation that is responsible for heat. So that's where we get our heat from. That warms all of our habitats and our different environments. And so that's a really, really important type of wavelength as well. And we're going to talk about infrared radiation and those wavelengths, because a big portion of our talk when we talk about ectotherms versus endotherms is going to be relative to their body temperature. And so as you can imagine, heat is going to be a really important role in regulating or maintaining body temperatures in your environment. And so the ability of these wavelengths to provide heat to our different habitats is super important. And then to the left of light, we see UV, which stands for ultraviolet radiation. And this is another form of radiation that has some impacts on us as people and on ectotherms as well. And we're going to talk about some of those impacts that are not so fun, but we'll get to that a little bit later. So this is the full spectrum of wavelengths that are found in our environment that are emitted from the sun. And so you'll see there's others as well. So there's things like gamma rays and X-rays and radio waves, but we're not going to focus on that. We're going to focus on UV, light, and infrared, as those are the ones that really have an impact on us in our everyday lives. So moving on from that, just wanted to give you all an understanding of where all this energy is coming from, where it all starts from up in the sun, and a little bit on how it's, how it changes and how it varies in different environments. So essentially there's going to be different intensities of radiation that is shining down or that's being emitted towards Earth. And so if you think about it, in the middle of the day, there's going to be stronger, there's going to be more direct sunlight. It's going to get hotter. And then if you think about it during even seasons, so during the winter, we have less daylight overall. The days are shorter and it's colder, right? Or it's cooler. And this is all relevant to how the Earth is positioned to the sun. So we know we orbit around the sun, right? And we also know that the Earth spins on an axis. And so all of these different forms of movement of the Earth in relation to the sun is going to impact the intensity of the sun and how much radiation is getting emitted towards us at different times. And that's going to be really important because we're going to talk about ectotherms, and they are heavily reliant on the sun and radiation to keep themselves warm. So this really is important to recognize that it's not always consistent. We're not always going to be experiencing the same temps, right? And so the intensity of radiation is going to vary seasonally, daily, even hourly. So we'll talk a tiny bit about clouds can have an impact on how much radiation animals and people are being exposed to. And so more cloudy environments are going to have a little bit more protection from radiation, in terms of clouds can actually reflect some of these radiation waves that are coming from the sun down towards the Earth. They can reflect it back towards space instead of letting the full impact of radiation reach down towards the Earth. But then again, if you think about it, seasonally too. So, all right. Now, we also have the atmosphere that surrounds the Earth. And so when the sun is emitting all of this solar radiation or this electromagnetic radiation towards Earth, we're lucky that we have the atmosphere because that absorbs and reflects some of the solar radiation that is getting emitted towards Earth. And so actually only about 48% of the radiation that is being emitted from the sun towards the Earth actually reaches Earth's surface, which is good because if 100% of it reached Earth's surface, we'd be in trouble. There'd be a whole lot more exposure to hot temperatures, direct sunlight, and that could really have some negative impacts. And so the atmosphere is essentially gases that are surrounding the Earth or other planets. And what it does is it absorbs some of that solar radiation, or just like the clouds, it can reflect some back. And so that's really nice. And we're going to talk about UV. That's one of the more harmful types of radiation. So there's actually 3 types of UV radiation. If I flip back really quick, you can see there's UV A, B, and C. So if you look to the left of the light spectrum again, you can see there's UV A, B, and C. And so all of UVC and most of UVB is actually absorbed by the ozone, which is a layer within that atmosphere or those gases. And that's really important because remember I mentioned there's increasing energy or strength of some of the different wavelengths. So if you see UVC is getting more further to the left on that spectrum. And so that's some really strong, or it's wavelengths that have a lot of energy, so more potential to be harmful. And so it's nice that all of that UVC and most of that UVB is absorbed by the atmosphere or the ozone. Okay, so again, only about 48% of solar radiation being emitted from the sun actually reaches Earth's surface. All right, so enough about solar radiation. We know where it comes from now. We know that there's different types of solar radiation. So the visible light that we see that helps plants, and then the heat, so the infrared radiation and that UV. But how does that impact animals or even people? And why is it important? So when we think about animals, we think about one of the most important things is maintaining body temperatures. So all animals have an internal body temperature, and they can't just let that body temperature range anywhere. They can't just be any temperature at any time. They have to control what their body temperature is. And actually, if animals keep their body temperature within an optimal range, meaning that it's a good range, then they can actually be more efficient, or they can be better at using the energy they have available. So energy isn't free, right? Animals have to eat food to get energy. And so maintaining energy and saving it and using it to the best of their ability is important. And all animals want to, maximize how much energy they have for things like growth and reproduction. And so when we think about maintaining a body temperature, we think about there's 2 ways animals can do that. And that kind of breaks animals into 2 different groups: endotherms or ectotherms. So endotherms are things like this panda, or mammals and birds. So birds are also endotherms. And these are animals that can burn energy to make their own body temperature, to generate their own heat, and to maintain their body temperature within that range that they like to fall within. So like I said, there's an optimal body temperature range for all animals that they'd prefer to fall within so that they can save energy and be really good at using their energy efficiently. And so there's endotherms, again, mammals and birds that can generate their own body temperature and maintain their own body temperature range. And then there's animals that cannot. So those are ectotherms. And this includes things like invertebrates, so insects, fish, amphibians, so like frogs and salamanders, and then reptiles will fall in our ectotherm category. So these are animals that cannot regulate their own body temperature. They cannot generate heat by burning energy like our mammals can. And so their body temperature is going to be regulated or controlled by their environment. So if the environment gets warmer, they're going to get warmer. If it gets a lot colder or cooler, they're also going to cool down. And so, like I mentioned, endotherms can regulate their body temperature just by generating their own heat. Ectotherms have to regulate their body temperature or kind of control what their body temperature is behaviorally a lot of the time. And so when I say behaviorally, I mean they will actually change their location or their position so that they can kind of control what they're exposed to in the environment and how that's going to influence how warm or cold they are. And so one of the biggest things they're going to behaviorally respond to is the sun and radiation and heat. So remember, heat comes from infrared radiation. And so they're going to respond and change their position or their location behaviorally to fall within conditions that allow their body temperature to try to be within that optimal range. All right, so one other thing I want to mention before I move on to ectotherms specifically, when looking at this endotherm, what we notice from this panda here is this panda is covered in fur or hair, just like we are. So we're mammals, we have hair. And so what mammals and birds and other endotherms also have going for them to help them with maintaining or regulating body temperature is they have insulation or insulating qualities. And so what that means is these are layers that help keep them warm. So bears are kept warm by fur or hair like this that's covering their whole body, as are all mammals that are covered in fur and hair. Birds are covered in feathers. So feathers help to keep animals warm and can help to keep them warm when it gets cooler. And so all of our endotherms have, or they even have, some animals have blubber or fat underneath their skin that can insulate them from colder temperatures. And so all of our endotherms have some type of layer that can help keep them warm as well, that our ectotherms do not have. So most of our ectotherms are covered in things like a shell or scales. So this is kind of cool because you can actually see the shell itself is made out of bone only, but then that bone can also be covered in layers of scales called scutes. So this is from a turtle. A turtle is an ectotherm because it's a reptile, right? We have things like snakes and lizards that are covered in, does anybody know, that are also covered in scales. And so you can see the scales are probably not going to provide as much insulating quality as things like fur and feathers, which are soft and warm. So just being covered in a thin layer of scales is not going to keep an animal like a snake, which is also an ectotherm and a reptile, as warm as some of our mammals. We have amphibians. So this is the skeleton of a frog. And so you can tell that that is not, so frogs and salamanders are oftentimes just covered in a layer of skin. And that skin is oftentimes really thin. So we're covered in skin, right? And we think, well, we can keep ourselves warm, but their skin is a super thin layer. It's called permeable, which means water and air can actually move through their skin. They can breathe through their skin. And so that really thin layer also is not going to do a great job at keeping them warm. And then we have things like invertebrates that also are just covered in exoskeleton. That's not going to keep them as warm either. And so for all those reasons, we have our ectotherms that are a little bit more exposed to environmental conditions. Even our fish, right, are just covered in scales, so nothing like this fur or feathers. So I wanted to mention that as well. That's one big disadvantage that our ectotherms have going against them in terms of not being able to maintain body temperature. Okay, so I mentioned that a lot of our animals, like our turtles, that only have these bony coverings or shells, or even the scales on top of those shells, that a lot of our ectotherms behave in order to maintain body temperature. So what is happening here is we see all of these, sorry about that, turtles out on this log in the water. And so what they are doing is basking. And so what they are doing when they're basking, does anybody have any ideas? They are exposing themselves to the sun. So they are soaking in solar radiation in order to warm themselves. So it is going to be warmer in the sun. And so if they position themselves directly in the light, that is going to help them increase their body temperature. And they are doing that so that they can fall within the body temperature range that they like to. So now there's nothing saying they have to stay in that sun. They chose to go there. So obviously their body temperature was not at a temp yet that they were happy with. So they all behaviorally moved onto this log and out of the water so that they could warm up and be exposed to the sun. So that's really cool. So that's one behavior that we see a lot. That is a perfect example of an ectotherm changing their location or their position so that they can be more exposed to solar radiation. So they are going to be pulling in more heat from that sun. And I should also mention that there are different ways in which animals can absorb sun and heat from the sun, or I should say heat and radiation, or sun rays from the sun itself. And so there's a couple ways that can happen. They can directly absorb it. They can have it transferred to them through other objects. So heat will actually work through kind of a spectrum, and so heat will always be transferred from from warmer objects to cooler objects. And so I'm going to talk about an example of this, a better example of this in the turtles, but I'll show you a good example of when animals position themselves so that heat will be transferred from that warmer object to their bodies, which is going to be cooler. This is more of an example of animals making themselves more directly exposed so they can absorb more heat. And then also heat and sun radiation rays can also be reflected off of surfaces. So it's likely that a lot of sun is also reflecting off the water and also onto these animals. So not only are they picking up direct sun and absorbing it directly, but they probably also have some reflecting onto them as well from the water, which is nice. And then lastly, kind of in relation to that, so some animals may not even behaviorally alter themselves to increase solar exposure or how much light they can absorb, but maybe even they can have some adaptations that help with this. So one way that they can do this is animals can have darker surfaces. So if you think about it, darker surfaces absorb more heat than lighter surfaces. So have you ever been outside and stepped on the pavement or the blacktop in the middle of the summer? It gets really hot, right? It can burn your feet. And so the same thing is true for animals or any surfaces. Have you ever heard not to wear a dark colored t-shirt out in the summer when you're going to be running around, because that's going to pull in more heat too, and that's going to make you hotter? Whereas if you wear like a white t-shirt, well, animals can alter, well, they can't alter, but they can have different colored surfaces. And so the color of that surface of an animal is going to impact how much light they're going to absorb. So the darker an animal is, the more light it's going to absorb, versus the lighter an animal is in color, they're going to reflect more light and they're not going to absorb as much of that light. So that's also interesting to think about. Okay, so this is when I was talking about This is my better example of how animals will position themselves on surfaces that will also transfer heat to animals. So not only are these animals fully exposed to the sun and absorbing some heat directly, but you'll also notice that these snakes are found on surfaces, especially the one on the right, that's a bit of a darker surface. So they're also going to have heat transferred directly to their bodies through those surfaces on the ground. And so whatever surface is warmer, it's going to transfer heat to the other. So likely that pavement and that rock is going to be warmer than the snakes. And so heat is going to get transferred, and that's going to help them balance their body temperature as well. There's some scientists that will actually go around and do surveys for snakes to learn about what snakes are in what environments just by driving around on the road. So like I was mentioning, the road can get really hot if you step on it in the summer. Well, some snakes like this, and they'll oftentimes stay on the road a little bit past sunset because they've lost the ability to get warm from directly absorbing the sunlight. But surfaces like rock or pavement that really heat up during the day, they'll hold heat for a little bit longer. And so snakes can stay on that surface and still continue to get heat even after the sun has gone down to help them regulate or maintain warmer body temperatures. And so scientists can go around and they can do what we call road cruising, and they can do surveys for amphibians. So when I say surveys, I mean they can go out and they can get counts of how many snakes they see or what species of snakes they see out on the road to get an idea of where some animals are, which is really cool. So that's a cool way we can study some reptiles or ectotherms like snakes, is by going around and road cruising to see which snakes are going to be out absorbing some heat from the pavement. But let's not just focus on reptiles. I mentioned that ectotherms can also be things like invertebrates. So there are some we think about basking, right? We think about reptiles like snakes and turtles basking out on logs. But some invertebrates like grasshoppers will also bask, and they'll go sit out in the sun to warm up because they still need to regulate their body temperature, right? And then we have animals like butterflies, which will behave even kind of in a cooler way, in that they've actually learned that, see how big the surface area of their wings are? They've learned that if they open their wings and position it perpendicular to the sun, which means they're gonna make their bodies as exposed to the sun as possible. So if the sun is coming from directly in front of me, they're gonna open up their wings so that the sun is shining directly at their wings rather than being parallel, where only slight angles of their wings would get the sun. They open up their wings directly to the sun, so that they have a greater amount of area collecting heat that can warm their body. And then on the opposite end of the spectrum, if they get too hot, they can turn their wings so that it's the whole face of the wing is not facing the sun, only the side. And so they'll absorb a lot less heat. And then they'll also close their wings, right? So it looks like only really one wing is being exposed rather than both. So they'll do things to minimize their surface area or maximize, depending on whether or not they want to absorb heat from the sun, which is really cool. And this is something in particular that some butterflies in colder regions up north will really do. Those butterflies will really focus on maximizing their surface area and facing their wings towards the sun so that they can increase the amount of time they can be out and active. Because if they get too cold, they're going to have to go hide and become inactive. And then that's less time that they can go out and forage and find food and eat and get any other energy that way. So these animals being able to keep their body temperature within a range that is healthy and safe for them is important. So they will do things behaviorally to increase the amount of time in which they can be out in the environment and exposed. So really cool examples of how other animals like invertebrates or insects will also behave in ways that allow them to get energy and heat from the sun. I thought this was a really cool example. So if we're here in Georgia, we probably all know what fire ants are, right? They're not fun. And so what I have here is a picture of a fire ant mound. And so what's really cool is that some fire ants have even learned to build their mounds or even change the shape of their fire ant mound in a way that increases or decreases that how much of the sun's rays can actually hit their mound. So they can make their mound in a way that increases the amount of sun that hits their mound, which will warm it up more. Or if it's too hot, they can build their mound in a way that's going to reduce the angle of sunlight that can hit their mound, and therefore cool down their mound a little bit. And so that's really interesting too, that I thought that ants will actually build their mounds in a way that can increase or decrease the body temperature of their, or not the body temperature, the temperature of their mound. Okay, so we've been talking a lot about heat and temperature, and so that's related a little bit more to, remember, that infrared wavelength or radiation. We also talked about UV radiation, and so that's another category of those wavelengths on that spectrum, right, that can be emitted from the sun towards the earth and therefore towards animals. And so UV radiation can be nice for us, for people. It produces vitamin D, it gives us one of our vitamins, which allows us to pull nutrients out of food, such as calcium. And so that allows us to have stronger bones. And so a little bit of exposure to UV light is good. We like vitamin D, but too much is harmful. And that's true for us and for animals. And so that's what can allow us to get burned a little bit, to get sunburn, right, if we're overexposed to UV light. So that's not good. And so we like to do things like wear sunscreen, put a hat on, protect our skin. But animals can't do this, right? So overexposure to UV light can be harmful to animals, especially animals like ectotherms. And what it can do is it can actually damage the DNA of animals like this frog or amphibians. And so oftentimes they will do things to try to reduce their exposure to UV radiation. And so one thing that they'll do is a lot of amphibians lay their eggs. So these are salamander eggs over here on the right. They will lay their eggs in locations that minimize exposure to ultraviolet radiation. And so this is a later stage of those eggs. This is after the embryos have developed into little salamander larvae. So these larvae are getting close to hatching out. You can see they have gills now. And tails and a head that is more distinguished. And so that's sort of a behavioral adaptation still, right? Salamanders and frogs positioning their eggs within wetlands in a place where they're not going to get as exposed to UV radiation so that they can minimize the impacts or the negative impacts and try to protect their eggs while they're developing. So that's pretty cool. And there are things, there are compounds that animals can make that, absorb UV radiation and protect them from damage, but they can only do that to a certain extent. And then just because they get exposed and DNA can get damaged doesn't mean they can't recover from that. They can recover and repair damages, but again, only to a certain extent. So really, an animal's ability to prevent and repair damage after it occurs is going to tell us a little bit about how tolerant, and when I say tolerant, I mean how capable animals are to live in these conditions. So certain animals are going to be able to take a little bit more UV radiation and exposure to UV radiation, and some animals aren't going to like it as much. They're not going to be able to handle those conditions. And so again, just based on how much they can handle it is going to kind of determine where animals can be found. And we see this as well in younger fish. So you can see in these salamanders, you can see, if you can see my cursor, these gills, these feathery looking gills coming off the head of some of these salamanders. So young fish also have gills. And so what we'll see is overexposure to UV radiation can even cause some gills not to be developed correctly. Animals may not develop correctly in these younger stages. They may not grow, so there may just be less animals altogether that don't make it and survive. And so animals even in the water will do things behaviorally to try to avoid overexposure to UV radiation. And so things like, if you think about tidal zones, or like the rocks really close to the end of a beach, or that's found where the water meets land, those rocky areas, or those tidal zones, animals will hide in crevices and try to get out of full exposure to the sun and therefore UV radiation. Some more behavioral ways in which they can avoid overexposure. And then there's one other way. So going back to heat a tiny bit, when we think about overexposure and things getting too hot or conditions becoming too harsh for animals to survive, when I think about overexposure and things like that, I think about desert environments. So deserts get extremely hot, right? It can be up to 120 degrees. And so a lot of animals, they may have an idea as to what a lot of animals are going to do in those environments. The idea is, so they're just going to stay out of the sun during those extremely hot temperatures, right? And they're going to hide. So a lot of animals, like spiders, or other animals that are found in desert environments, are going to go into burrows. So they're just going to go underground. They're going to avoid those conditions altogether. And then they're going to come out at night once things cool down and once that extreme exposure is minimized and reduced. And so that's a good way in which they can try to help protect themselves. And so that's really important for ectotherms, is to be able to behavior, essentially all those examples I just provided were examples of animals behaviorally altering their exposure to conditions or increasing their exposure. So if it's too cold, right, they're going to go out and do things like lay in the sun and fully expose their shells in their bodies so that they can warm up. So it's all dependent on where their body temperature falls in relation to what they wanted at their internal body temperature. And so I hope you've all found this interesting and learned a little bit about ectotherms and how they can try to use the sun or protect themselves from the sun to maintain body temperature so that they can live healthy lifestyles. And so I hope you all learned something and enjoyed this talk, and I hope you join us again in the future. Thanks so much. Bye, everybody.